Hello everyone, this is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of data mining video lecture series, in this lecture we are going to discuss FP3 mining. So previous lecture I already explained how to construct frequent pattern trees from the transactional databases. So in this lecture we are going to see one more example and we'll also have a quick recap on yesterday's problem, that is a previous lecture problem, and then I'm going to explain how to mine the patterns from this frequent pattern tree. So in this we are going to review of FP3 construction and then mining the frequent pattern tree. So this is a tree, the frequent pattern tree FP3, that we construct from this transactional database based on the procedure. So that is first we have to find out the step 1, we have to find out the frequent one item sets, and then we have to order the frequent one item sets, that is a frequency decreasing order. Then we have to process each transaction. First we need to create a root node with the label null, and then we have to process each transaction at a time. So the first transaction, while processing this first transaction or constructing the frequent pattern tree for this transaction 1. So first we need to sort these items in this transaction. So transaction 1 has items I1, I2, I5, and these items need to be ordered as per the frequency decreasing order. That is total 5 items in this, like I2, I1, I3, I4, I5, and this is the order as per their frequency or the support count. I2 is the highest, 7. So now this transaction T100 has 3 items, I1, I2, I5. So now if you arrange this, then I2 will be the first, and then I1, then next I5. So this is the order of items. Now we have to construct the frequent pattern tree. So first we create, we have already created the root node with the label null. Then we have to create a node I2, and then that is all this we have to give the frequency count as 1. That means we have to create a node I2 with a frequency count 1, and then I1. So I1, this one, and with the frequency count as 1, and next I5, and this is the I5. This is the way we construct. And similarly for the next transaction. So here the second transaction, if you construct, the second transaction has 2 items like I2, I4. So these 2 items are in the order as per this. So this, now we are going to include this in this frequent pattern tree. So I2 again, so then previous I1 count is, I2 count is 1, so the support count, and it will be incremented by 1. Next I4, so this is the node that we have to create with the frequency 1. So like this we will add all the transactions information, that is in the form of a frequent pattern tree. So in this case you can to navigate easily, we'll maintain the node link here, that is you can see, and this I2 is the node link is maintained here. Then I1, these are all like a dotted arrows are linking the same items, and similarly like I2, and this is another I2, and this is another I3. So like this we'll construct a frequent pattern tree. Let us quickly see another example, like same how we can construct a frequent pattern tree. So here this is a transactional database which has 5 transactions. Each transaction items are mentioned here, F, C, D, G, I, M, P, that is in first transaction. And now the frequent item sets, we have to order these items, because first step we have to find out the frequency of each item. So then we have to order the items. So, and this is the frequency, and if you could arrange the items that is one item sets in the order, then we'll get this order. So then each transaction items need to be arranged in as per that order. So this one, so sorry, these are the frequent item sets. This is the order. So this is the order, and similarly the second transaction also, all items are arranged as for this order, like for the remaining all transactions. So next, from this you can just quickly recall the first scan, that is we need to scan the database once and find the frequent one item sets, that is a single item patterns, and sort the frequent items in a frequency descending order, that is F list. Like F is the highest frequency, C is occurred same, like number of times is 4, and A appeared in the transactional database 3 times, B 3 times, M 3 times, and again P also 3 times in that transactional database. Next, the third step, scan the database again to construct the frequent pattern tree. So now let us just quickly observe here the minimum specified threshold or a minimum support equal to 3. That means if any item set is a frequent item set, that's the frequency, the frequency or the support count should be greater than or equal to 3. So in this case, now we have to construct the frequent pattern tree. So first, if you consider the transaction 1, then transaction 1 has items F, C, D, G, I, M, P. So FAC. So here the frequent item sets, these are the frequent item sets. That means one item frequent item sets, that is their minimum support is greater than or equal to 3. So now we have to arrange the items, one item sets into the order. So now FCAMP, FCAMP, and this is the path we need to construct for the first transaction. And the second transaction, we have, these are the frequent, right? The transaction has these items, but these are qualified as a one item frequent item sets. So then FCAB, M, FCAB, B, and M. So from this is a previous path we have constructed like this, and this is the new path because of the first B appeared and then M appeared. So that's why we have to construct a separate from this point. Next, FB, F, and from up to F, and the F frequency of F will be incremented by 1. Then there is no path, right? So leading, so then we have to construct a separate node for B and give the support count as 1. So then C, B, P, that is fourth transaction. C, because there is no node, that is from the root to reach the C, so we have to create the C with the frequency 1, then B, and next, and then P. So this is the path we will construct, that is the result of a fourth transaction. Next, a fifth transaction, FCAMP, FCAMP, the same path already exists, so that we can simply increase the support count of each node value, like FCAMP. So this is the way we construct the frequent pattern tree. This is a simple. So now we have to understand how to mine the frequent patterns. How to mine the frequent patterns from the frequent pattern tree. So we'll start from each frequent length 1 pattern as an initial suffix pattern. So construct its conditional pattern base, that is a sub database which consists of a set of prefix paths in the FP tree that is co-occurring with the suffix patterns. Then construct its conditional pattern base, that is FP tree, and performing mining recursively on the tree. So the pattern growth is achieved by the concatenation of the suffix pattern with the frequent patterns generated from a conditional FP tree. So let us apply this procedure of mining the frequent patterns to this example, continuous example. So here this is a FP tree that we have constructed for the example transactional database. So now we have to find out the conditional pattern base for each item and this FP tree and also the conditional FP tree, and from that we can generate the frequent patterns. So let us observe how we can construct this conditional pattern B, conditional FP tree and the frequent patterns from this frequent pattern tree. So now, so there are like items like I1, I2, I3, I4, etc. So let us select any item. Like let's suppose if you take I1, so we have to find out the conditional pattern base. So at I1, the conditional pattern base are nothing but a paths like, so I1 here, how many? This is 1 and next, and this is another one. Okay, so the paths we will consider like I2, I1 is a one path and I1 itself is a one path with respect to this item 1. So as per this as per this, and we have to consider the prefix of these paths. So then I2 will be only available in the prefix of this I1 conditional pattern base. So then the I2, the frequency, like suppose if you could observe, like there are paths like I2, I1, the frequency is 4. Okay, because this is the last item in this path. If you consider this as a path, and the last item frequency will be the frequency of this item set. So then this is the frequency, and similarly for I1, its frequency is 2. So both the, let us say minimum support is equal to 2, and then these are the frequent item sets. So now we have to consider the prefix of this prefix of this two paths. That is, we have to exclude this item I1 because we are going to build the conditional pattern base for this item I1. So if so, then I1 is going to have the I2 4 as a conditional pattern base. So that is conditional pattern base. So once we find the conditional pattern base, then we have to construct the conditional FP tree. So it is simply constructing conditional FP tree. So first we have to create a root node with the label null, and then this is a root node with the label null, it is an empty, and then we have to create I2, that is with the for support is 4. This is a conditional pattern conditional FP tree for item 1 I1. So this is the conditional FP tree. So now from this we are going to generate the frequent patterns from this conditional FP trees. So that is the combinations will take I1, I2. This is only the one possible combination. So I2, I1 with support 4. This is only the one frequent pattern that is generated from this conditional I1 conditional pattern base. And similarly, let us take another item to understand. So let us take this item like I5. So this I5, and if you observe the paths to reach the I5 in this frequent pattern tree, this is 1, that is you can consider this path, and next this is another one. Okay, next only we have the 2 conditional pattern bases. So that is, these are the paths to reach the item set I5. So the conditional pattern base would contain I2, I1, I2, I1 with the frequency 1, because I5 frequency is 1 along this path, and next another one is I2, I1, then I3. So what is the frequency? It is also 1. Frequency is also 1. So now we have to find out the conditional FP trees so that we can construct, right, conditional pattern base. These are the conditional pattern bases. From this table you can observe this. These are the conditional pattern bases of this item I5. So now we have to exclude this I3 because its support is equal to 1 from this. Yeah, support equal to 1. So we have to exclude that. So then the conditional FP tree would contain I2, 2, I1, 2. So then we'll construct the conditional pattern FP tree, that is root, and this will be I2, and then another I1, okay, with the frequency 2, that is a supporter 2. So next we can generate the frequent patterns, that is the combination of I2, I5, I1. So these are the different patterns we could generate: I2, I5, I1, I5, I1, I2, I5, all together, 3 items together. Similarly, and for I3, if you look at I3, how we can find this conditional pattern base, and how we'll construct this conditional FP tree. So here I4 paths need to be considered to reach the I4. So this is, where is the I4, and this is a I4, and next where is that another one? Yeah, this is another one. Okay, these two are the I4. So then we'll write this conditional pattern basis excluding that item, that is I2, I1, I2, I1, and the frequency is 1. So that is this one. Next another, that is I2, I4. So then we have to exclude that particular item. So then I2 and its frequency is also 1. So these are the, you can see here, these are the two. The conditional pattern base have these two. Next, so next, because this I1 in this case I1, the minimum support threshold is not greater than or equal to the specified threshold value. So then that will be excluded. So then the conditional FP tree for this would contain only the I2. So then the frequent pattern generated is I2, I4 only. I2, I4 with the support to this one. Like that, we'll construct the conditional pattern base, conditional FP tree, and the frequent patterns. From those FP trees, we could generate the frequent patterns. If you could summarize what we learned from this frequent pattern tree, the FP growth method transforms the problem of finding a long frequent patterns into the searching for shorter ones in much smaller conditional databases recursively, and then concatenating the suffix. It uses the least frequent items as a suffix, offering a good selectivity. The method substantially reduces the search cost, that is compared to the a priori. When the database is large, it is sometimes unrealistic to construct a main memory based FP tree. So the main memory could not accommodate the FP tree. An interesting alternative is to first partition the database into set of projected databases, and then construct the frequent pattern trees and mine it in each projected database. So this process can be recursively applied to any projected database if its a frequent pattern tree still cannot fit in a main memory. So thank you for watching. So next lecture we'll see the classification problem.